In this video, we're going to look at factoring a sum or difference of cubes. I'm going to start off by writing down some of the cubes we'll use most often. And I'll do it over here. So if we have 1 raised to the third power, it's 1. 2 raised to the third power is 8. 3 raised to the third power is 27. 4 raised to the third power is 64. 5 raised to the third power is 125. 6 raised to the third power is 216. 7 raised to the third power is 343. And 10 raised to the third power is 1000. As demonstrated in class, we're going to have to be able to learn to identify that the numbers on the right side are the cube of a certain base. When I talk about the base, I'm talking about it was a 1 that was cubed to make 1. It was a 2 that was cubed to make the 8. It was a 3 that was cubed to make 27. It was a 4, a base 4 that was cubed to make a 64, and so forth. So these are the bases we're going to need to learn to identify. All right. With cubes, let me see if I can shrink it a little bit so you can still see those. With cubes, it's still going to be a two-term phrase like it was with the squares, but we don't need it to necessarily be a plus or a minus. Cubes actually work with both of them. It can be a sum or difference with cubes. The first step is the same. You want to see if, if they are either squares or cubes. With the 3 as an exponent, it's a big tip-off that it's going to be a cube. The base being cubed in the first position is an x. In the second term, the base being cubed is a 5. Now, cubes factor a little larger than squares do. So you're going to open up a 2-term phrase and a 3-term phrase. And on this first example only, I'm going to go ahead and label how we get each piece. First, once you've identified the bases, our 2-term phrase is the first base, the second base, and the same sign as in the original problem. So this is still going to be the first base. This will be our second base. And the sign will be the sign from the original problem. For the trinomial part of it, to get the first position, we square the first base. X squared is x times x. To get this last term, you'll square the second base. 5 squared is 5 times 5, which is 25. Let me write that down. This is going to be our first base squared. This will be our second base squared. To get the middle term, we're going to multiply our two bases together. X times 5 is 5x. And the signs. This sign will always be a plus. It's never going to be anything different. But this sign is going to be the opposite of what was in the original problem. So if this one was a plus, this one is a minus. Let me write those down. The middle term is our first base times the second base. This sign is always plus. This sign is the opposite of the original problem. Now there we have all of the directions written down, and we will do this over and over and over again for the sum and difference of cubes. Let's look at our second example. Start off by identifying what's being cubed in each position. In the first position, it is an x that's being cubed. In the second position, it is a 4 that's being cubed. Open up your 2 parentheses factors, a 2-term and a 3-term phrase, because cubes factor a little bit larger than squares. The first base goes in the first position. This second base that we identified goes in the second position with the same sign as in the original problem. To build the trinomial, we take the first base we identified and square it. X times x is x squared. To get this last term, we're going to take the second base and square it. 4 squared is 4 times 4, which is 16. This sign is always a plus. This middle term is made up by multiplying the first base times the second base. That's 4x. And this sign is the opposite of what was in the original problem, so it'll be a plus sign. Another cool thing is that even though this is a trinomial, in the cube factoring, this is prime. Let's do a couple more. Here, we start off by identifying what was cubed in each position, x and 3. Then you open up a 2-term phrase and a 3-term phrase. For the 2-term phrase, it's the two bases with the same sign as in the original problem, never going to be any different. In the second parentheses, it's a trinomial, so we're going to build it. The first base squared goes in the first position. X times x is x squared. For the last term, it's our second base squared. 3 squared is 3 times 3, which is 9. Our middle term is made up of what we get when we multiply the first base and the second base together. X times 3 is 3x. This sign is always plus, never going to be any different. And that sign is the opposite of what we had in our original problem, which is a plus. And we're done. One more and then we'll go to the next video. Minus a cubed. I'm going to start off by identifying what's being cubed. That is a 1 that's being cubed. And that is an a that's being cubed. Now you can't rewrite it. This is the order that it's in and that's how you take care of it. But you do exactly the same thing. We're going to have a 2-term phrase and a 3-term phrase. First base, second base, with the same sign as in the original problem. The first base squared goes in this position, so 1 times 1 is 1. The second base squared goes in the last position, a squared. This is always a plus. This sign is the opposite of that one. And in the middle, it's the product of our two bases. 1 times a is 1a. All right, I'll see you in the next video.